So you are welcome. Let us talk about equation of motion. So every system in motion has these following variables that we are coming to talk about. And these variables help to give some specifics about the system in motion. It helps to give some specifics about the system in motion. So the first thing we talk about is the initial velocity of the system. Initial velocity of the system. Then the second one is the distance covered by the system. Then the time taken to cover the distance. The time taken by the system to cover the distance in the motion. Then acceleration of the system. Acceleration of the system. Then the final velocity of the system in motion. Then the final velocity of the system in motion. So let's consider a moving vehicle. Let's consider a moving vehicle. Let's say it started from rest. So if the system is starting from rest, then it has an initial velocity, which is 0. And as soon as the vehicle starts moving, it starts covering some distance with respect to time. Then it starts gaining velocity. As the velocity keeps changing with time, then the system gains acceleration. So a system in motion or a car in motion has initial velocity when it is at rest. And as soon as it starts covering a distance in some specific time, it gains velocity. And when the velocity keeps changing, the system gains acceleration. And when the system comes to a stop, it gains its final velocity. So the initial velocity is the velocity at which the system started moving. And the final velocity is the velocity at which the system had before stopping or had when stopping. So these variables help to give specifics about a system in motion. So there are 3 main equations that are used to identify these variables of a system in motion. There are 3 main equations. The first equation is V equals U plus 80. V equals U plus 80. So in this equation, it has the final velocity, initial velocity, acceleration, and time. So you can find these 4 variables in the problem using this equation. Let's say you want to find acceleration. Given the initial velocity, final velocity, and time, you can use this equation to find that variable. The second equation is S equals UT plus half AT squared. So S is a symbol denoted for distance, U is for initial velocity, T is for time, and A is for acceleration. So with the second equation, you can find distance, you can find initial velocity, you can find time, and you can also determine acceleration. Then the last equation is V squared equals U squared plus 2AS. V squared equals U squared plus 2AS. So with this one, it has final velocity, initial velocity, acceleration, and distance. So this equation has no time within it, so you can't use this equation to determine time if you have these variables. So these are the equations that are used to find specifics of a system in motion. If you want to know these kind of variables the system has in motion, then you can use this equation to determine them. And you're supposed to note when to use the equations, the variables you have in the equation, and what you're asked to find determines the kind of equation you will use in solving the problem. So now let's look at some specific problems that we can use these equations to solve. The first one is a car with an initial speed of 1 meter per second was in motion for 10 minutes, and then it came to a stop. The velocity right before it stopped was 5 meters per second. What was the constant acceleration of the car? So let's look at the solution of this question. So we first state out the given variables in the question. So we have initial velocity, we have final velocity, we have time, and we are looking for acceleration. So now picture the 3 equations of head. Equation 1, equation 2, equation 3. Which of the equations will be suitable for solving this problem? We have equation 1, which is V equals U plus AT. Equation 2, s equals ut plus half at squared. Equation 3, v squared equals u squared plus 2as. Which of these equations will be used to solve this problem? So picture it out. We're having initial velocity, time, and final velocity. So the perfect equation for this problem is equation 1, which is v equals u plus 80. V equals u plus 80. So we are looking for acceleration. So therefore we have to make acceleration the subject of this equation. So acceleration gives us v minus u all over t. Final velocity minus initial velocity all over the time. So note, you always convert, or note that all the units or the variables are in their standard unit. So acceleration is meter per second squared, velocity is meter per second, time is second. So you make sure all these parameters are in their standard unit. So the time in the question was given as 10 minutes, so we have to convert it to seconds, which is 600 seconds. So after all the conversions, we do our substitutions into the equation. So therefore, we substitute our v, substitute the u, then substitute the time t. So then final velocity is 5, initial velocity is 1, then time is 600. So after substitution, then computation, we have the acceleration of the car to be 6 times 10 to the power minus 3 meter per second squared. 6 times 10 to the power minus 3 meter per second squared. So this is the acceleration of the car, which had an initial speed or initial velocity, a final velocity, and a specific time at which it was moving, and we're asked to find the acceleration of the moving car. Now let's look at another question. A cycle covered 2 kilometers in 8 minutes, and the initial velocity of the cycle was 1 meter per second. Find the acceleration that the cycle had in its motion. Find the acceleration that the cycle had in its motion. So let's solve the problem together. So first, we'll state out what we have in the question. We have distance, we have time, then we have initial velocity. So our time was 2 kilometers. So we change it to meters, which is 2,000 meters. Then we have our time, which is 8 minutes. We change it to seconds, which is 480 seconds. Then we have the initial velocity, which is 1 meter per second. So now picture what you have and what you are looking for. We have time, we have initial velocity, we have distance, you are looking for acceleration. So picture the equations, equation 1, equation 2, equation 3. Equation 1, v is equal to u plus 80. Equation 2, s equals ut plus half at squared. Equation 3, v squared equals u squared plus 2as. And we are looking for acceleration. Looking at the parameters we have here, the perfect equation to solve this problem is equation 2, which is s equals ut plus half at squared. S equals ut plus half at squared. We have distance, we have initial velocity, we have time, we are looking for acceleration. So if we are looking for acceleration, then we have to make acceleration the subject of the equation. So we are bringing mathematics here, chain of subjects. So we will first send ut to the other side of the equation, which becomes minus. Afterwards, we multiply the left side of the equation by 2 and right side by 2 to cancel the half on the right side. So after the multiplication and cancellation, we divide through by t squared to get a to be equal to 2 into bracket s minus ut all over t squared. So this is the acceleration after change of subject. So after changing the subject, we will do our substitutions since we have all our parameters from the question. So our distance s is 2,000 meters. Our initial velocity is 1. Our time is 480 seconds. So we do all the necessary substitutions. After that, we compute. So leaving our solution to be 0.0132 meter per second squared. So acceleration of the cycle in its motion is 0.0132 meter per second. Now, another question. A toy is accidentally dropped by a kid from his roof. The final velocity of the toy before it reached the ground was 8 meters per second. Find the height of the building. Find the height of the building. We have a kid holding a toy and he accidentally dropped it from the roof to the ground. And the question only gave us the final velocity at which the toy moved onto the ground. And you're asked to find the height of the building. So let's solve the problem together. So firstly, we have final velocity and we have our acceleration. We have our acceleration because the toy moved from the top of the building onto the ground. So that motion was influenced by acceleration due to gravity. So therefore, our A here changes to G. Our A here will change to G. So we have acceleration, which is 9.8 meters per second squared. And we have our initial velocity, which is 0. So at first, the toy wasn't moving from the roof. It wasn't moving. It had no acceleration. So it moved from 0 to 8. So our U is 0 and our V is 8. So therefore, we have our V, we have our A, we have our U. We're looking for height, which is S. It is a distance. So which equation will be suitable for this problem? We have equation 1, equation 2, and equation 3. So in equation 1, V is equal to U plus AT. In equation 2, S is equal to UT plus half AT squared. In equation 3, V squared equals U squared plus 2AS. So picture what you have, the parameters you are given, and what you are looking for. The perfect equation for this problem is equation 3. So V squared equals U squared plus 2AS. And we are looking for distance, S. So change of subject comes in here. So what we will do is we will move U squared to the other side of the equation, which becomes V squared minus U squared. Then the other side becomes 2AS. We are looking for distance, which is S. So we divide through by 2A. Therefore, we are having S to be equal to V squared minus U squared all over 2A. So our A here changes to G, which is the acceleration due to gravity, as we discussed earlier. So our A changes here to G. So after change of subject, we will do our substitutions into the equation. So final velocity is 8. Initial velocity is 0. Acceleration due to gravity is 9.8. So we do the substitutions, then you compute for height, which is S. So after computation, we are having the height to be equal to 3.27 meters. We're having the height to be equal to 3.27 meters. So the height of the building at which the toy was dropped by the kid from the roof is 3.27 meters. Now, here's another question that we want to try. Find the final velocity of an object that traveled a distance of 500 meters with an initial speed of 2 meters per second. And acceleration of the object was 0.5 meters per second squared. So here we are looking at final velocity. We are finding final velocity of the object. It had a distance it traveled. It had initial velocity and acceleration. We are looking for final velocity. So there's no time inclusion here. So let's solve the problem together. Firstly, we will state out the parameters given in the question. We have distance 500 meters, initial velocity 2 meters per second. Then we have acceleration, which is 0.5 meters per second squared. So with this problem, we are looking for V, which is the final velocity. And the perfect equation is equation 3, which is V squared equals U squared plus 2AS. Since there was no time inclusion in the question, this is the perfect equation to solve the problem. So we therefore do our necessary substitutions. We have our U, which is 2. We have our acceleration, which is 0.5. Then we have our distance, which is 500 meters. So after the substitution, we're having V squared to be equal to 504. Having V squared to be equal to 504. But we want V. So therefore, we take square root of both sides. So the square root of 504 is leaving us with 22.5 meter per second. It's leaving us with 22.5 meter per second. So therefore, the final velocity of the object traveling in the distance of 500 meters has a final velocity of 22.5 meter per second.